Welcome to this session. In this session, we're going to continue to apply the definition of function. Okay, we continue to emphasize the definition of function. And once again, the definition of function is that a function is a rule that assigns to each input. Here we're gonna use A because the input for trig functions are angles. So I'm gonna just change this a little bit so it doesn't get confused with the coordinates, okay? But it's still the inputs, okay? The meaning doesn't change, right? Inputs now are angles, and our angles are the inputs, and the outputs are, any one of these trig functions. And today, this lesson, we're gonna study sine function, just study sine function, okay? So once again, we start from the stage set, okay? I always want to remind you, okay? The centerpiece of trigonometry is not about those special angles, okay? It's not about those special angles. The centerpiece of a trig function is about the stage set, and it's about the definition of the 6 trig functions, right? And there are more function definition is yet to come, but that's all. The special angles are to enhance understanding of definition. So with that in mind, I would apply the definition to sine function in this lesson, okay? So once again, we know that A is an angle in standard position, and the point on the terminal side of the angle other than the origin. Okay, so that point has coordinates, right? X coordinate, Y coordinate. X is the horizontal measurement, Y is the vertical measurement. And R is the square root of X squared plus Y squared. Okay, so in that, under these stage set, all of these assumptions, under these assumptions that we define this function, the angle is A, and the A, get the rule to apply to A, it produces a ratio. So input is angle, output is ratio. We have talked about Y unit circle, right? Well, once we understand Y unit circle, then we start to study lots of these trig functions on unit circle for its convenience, and then this added convenience for our study. So the first choice I'm going to choose is I'm going to choose an angle, and this angle is 30 degrees. Okay, 30 degrees. And we know that 30 degree in radian is pi over 6, right? In the conversion of degree to radians we talked about, right? To convert degree, what do we need to do is that we take the degree, okay, and we multiply by pi over 180 degrees. Okay, so as a result, we get pi over 6. We get pi over 6. Okay, and we also understand what pi over 6 is, right? We also understand what pi over 6 is. So here we measure the angle. Okay, we're going to do the movement. Okay, follow the definition. We measure the angle from the standard position. Notice that I changed the color of standard position to pink. Okay. So from now on, we will consistently using standard position as the pink color. And we measure the angle, and the terminal is right here. All right, this terminal right now is right here. So I'm just going to erase it and just show you that movement of measurement. Okay, show that movement of measurement. So this angle is pi over 6. Okay, and because we can choose any point on the terminal, right? So we're going to choose the point at the crossing with the unit circle. We're going to choose the point at the crossing of the terminal with the unit circle. And our goal is to identify this point. we want to identify this point. If we can identify this point, right, x, y here, right? If we can identify the coordinate of that point, then we'll be able to find y over r. Okay, so the meaning of that point is, right? So this is, of course, that's x comma y. So let me see if I can quickly put it there, right? The x, I'm gonna put that xy over there, that xy, I already have an xy there. So let me just put it in the right place. Okay, so it's 1.5 to see if that will make it, right? So that point xy, perfect, right? So xy, okay, 1.5. Okay, so that's just, that's just I'm using the software to mark that point, Okay, so in order to determine the coordinate of this point, right, x, y, x is the horizontal, the red, y is the vertical, which is the blue, okay? And how about the radius? The radius is 1 because it's on unit circle, the radius is 1. So we want to know what is the value of the blue and what's the value of the red. Well, as we have learned before, this is a trigonometry. This is where trigonometry comes in. Since this angle is 30 degrees, right, pi over 6. Okay, let me use a little color. Okay, so this is a 30 degrees, and on the other side, we reflect this line over on this side, so we make another 30 degrees. So this whole thing is 60 degrees. Okay, so this whole thing is 60 degrees. Okay, this whole piece, this whole angle is 60 degrees. 60 degrees, and this side is 1, and that side is 1, and this side is going to be what? Right? This is 60 degrees. The three angles are going to be 60 degrees, right? Because this is isosceles. The two sides are the same. So these two angles, which add up to be 120, they're going to be 60, 60 each. So this is a unilateral triangle. Unilateral triangle, that means all three sides are of the same length. Since one side is 1, so all sides are 1. If this entire side is 1, the blue is going to be half. The blue is going to be half. Okay, the blue is half. The blue is half. How about the red, right? If the blue is half, what will be the red? Okay, so we know the red side is x. The blue side is half. So we know that already, right? So now we want to find the red size. The red side is x, right? So it's x squared. We're going to use Pythagorean theorem plus y squared. Y squared is half squared, right? Half squared. And that's going to be equals to 1 squared because it's Pythagorean theorem, right? The hypotenuse equals to 1. With that done, we're going to solve for x, right? We're going to solve for x. So by Pythagorean theorem, that's what we got. Solving for x. We're going to solve for x. Solve for x. Solving for x, what do we get? Okay, so let's do it step by step. X squared plus a quarter is equals to 1. And we're going to subtract a quarter on both sides. We're going to subtract a quarter on both sides. So x squared is equals to 1 minus 1/4. 1 minus a quarter is 3/4. 3/4. Okay. Now, we're closer to solving for x, so we're going to take square root on both sides. We're going to take square root on both sides. So the square root of x squared is equals to the square root of 3/4. Okay, the square root of 3/4 is the square root of 3 over square root of 4, which is 2. All right. So now, what is the square root? Put that away. I'm going to use that later. What is the square root of x squared? What is the square root of x squared? That's right, absolute value of x. Okay, absolute value of x. Okay, equals to root 3 over 2. Root 3 over 2. Okay, but because x itself is a positive under the circumstances, right? X is a positive in the first quadrant, okay? So because x is positive, as the point x comma y is in the first quadrant, is in quadrant 1. Therefore, the absolute value of a positive number is the same as the number, which is equals to root 3 over 2. Okay, so now we found x, right? So the red is root 3 over 2, the blue is half. So we found the coordinate of this point, okay? Now we got this point, so we're gonna mark it, okay? I'm gonna mark, but we're gonna have to erase because these two software don't talk to each other, okay? So let me write it in the color coordinate situation. Okay, I'm trying to do that. So this point, okay, using the parentheses, okay, so this point, the red number, which is for the red line, is root 3 over 2. And the blue, which is the vertical line, is half. Okay, so this is the whole process of finding the coordinates, finding the coordinates. Once we found the coordinates, then we can find sine, cosine, tangent, cotangent, cosecant, and secant, right? So in this section, we're interested in sine. So what will be the sine value for this pi over 6? The sine value for pi over 6, of course, is going to be sine. This is how we write it, okay? Sine of pi over 6, right, equals to, by definition, it's y over r, right? Because we have chosen r equals to 1, so it's going to be y. And what is y? Y is the blue, which is equals to half, Okay, and similarly, we actually also find cosine pi over 6 at the same time. We find cosine pi over 6. Cosine pi over 6 is x, and x equals to root 3 over 2. Root 3 over 2. Okay, and you can continue to find the rest of them. Okay, so now we're only just going to focus on sine and cosine. So we have this point covered. So let's look at another scenario. Okay, In this case, okay, I'm going to measure angle from the standard position. I'm going to measure angle from the standard position. Okay, and this angle is going to be measured from standard position, right? From standard position. And let me grab the pink, right? Measure from the standard position. Let me just do counterclockwise and overlap here, right? And this angle I choose this angle to be, okay, right here, 5 pi over 6. Okay, so this angle is going to be 5 pi over 6. What is the degree for 5 pi over 6? What's the degree for 5 pi over 6? How do we convert radian to degree? 5 pi over 6, right? We have a lesson to do that. So please go back to check that section. By 5 pi over 6, we want to convert it to degree. How do we do it? We're going to multiply 180 degree divided by pi. Divided by pi. Okay, what would that be? What would that be? Simplify pi and pi reduced, right? 180 degree multiply 3, and that's going to be 150 degrees. 150 degrees. Okay, so this is the angle, and that's the terminal. That's a terminal. And now this is the time we're going to use reference angle, right? We need reference angle because we're going to have to, work out the coordinates. We're going to have to work out the coordinates. Okay, so let's see, what are the coordinates, right? What are the coordinates? And I should have an XY there. It's just not being marked in the right place. So I'm going to make it the right place. So this is going to be negative 1 and 0.5. See if that works. Okay, that should work, right? XY there. Okay, so there's also X and Y there, right? And that XY, okay, that XY is going to be corresponding to the red and the blue. Red and the blue. Okay, for this red and blue, the red is X, the blue is Y. And this reference angle is 30 degrees, right? So for this matter, we can use the same method to create a unilateral triangle, right? So this blue piece is 1/2, but the red piece, the length of the red piece is still √3/2, just like what we did earlier in the previous triangle. But this red piece is on the negative side of the origin. Therefore, the red here is negative √3/2. Okay, so now let's write down the coordinates here. The coordinates for this point, this dot, okay, with that terminal. So this point is going to be negative √3/2. I should write a red number here, should I? Yes, okay, so let me make that a red number. Okay, the red number is negative √3/2. Oh, that's so ugly, sorry. Okay, negative √3/2 over 2, and the blue is still +1/2. Okay, so that's this point. Once we get that, so we can express it with sine, cosine. Okay, we can express it with sine, cosine by applying the definition, Sine of 5 pi over 6. Okay, I'm gonna use more radians. Okay, is y. Y is the blue, which is half. Okay, and cosine 5 pi over 6 is negative square root of 3 over 2 by definition. Okay, the red number is cosine, the blue number is sine. Got it? So you see, we apply definition, right? Measurement of the angle and reference angle. Here we have a reference angle. This reference angle plays an important role, right? Because it allows us to see that unilateral triangle, right? It allows us to see that unilateral triangle. All right, so let's see the next special angle we have chosen. Okay, the next special angle we have chosen, and this angle I have chosen is measured, of course, from the standard position. Well, counterclockwise, I don't have to measure this way, but this time I measure this way, and this angle is 7 pi over 6. Okay, 7 pi over 6. So I'm going to just mark this angle. Okay, I'm going to mark this angle as 7 pi over 6, this angle. Okay, 7 pi over 6. It has a reference angle. The reference angle is the positive acute angle between the terminal and the x-axis, and this is pi over 6 one more time. Okay, and you can see if I construct a triangle identical with the one just over on the other side, I have another unilateral triangle. Right? So everything we did on the first quadrant works, right? So this is a half, and this is root 3 over 2. But we have to consider the fact that this point is in the third quadrant. In the third quadrant, x is negative, y is negative. X is negative, y is negative. So this point, okay, this point, I think we also have the xy marked before. Okay, the xy marked, I think I should just make it a -1, -0.5 to make that mark show up, right? So we can see it. So xy. So this point. So what the coordinate of this point? The coordinate of that point is right. It's a pair of red and blue number. So I'm going to use that color coordination. The red number, okay, is a negative, the x value, right? It's the x value. So let me use red. Negative root 3 over 2. And the blue number, which is y, the vertical, is -½ not a +½ because the point is in the third quadrant. Okay, so you can see when we apply definition, and when we use the definition, we have to consider where the point is, which quadrant, right? We apply definition. All right. The next case. Okay, and this time I measure an angle. Okay, I measure the angle, of course, still from the standard position. That's going to be my input. Oh, hold on a second. I think I didn't do the sine value, cosine value, right? All right, so let's do the sine value, cosine value, okay? The red, my bad, okay. The red number, right, is negative √3/2, because I want you guys to use the notation properly. Okay, so I need to set an example for you. And this point and the blue number is a -1/2, right? So when we write down for this, when we look at the function, right? So sine of 7 pi over 6, 7 pi over 6, okay? Convert that degree. Okay, 7 pi over 6 is going to be, this is a y value, is -1/2, -1/2. And cosine 7 pi over 6 is going to be the red number, the x, right? Which is going to be -√3/2. Okay. All right, so let's look at the next scenario. Okay, you can see I arranged these terminals in all four quadrant, okay? So now, of course, we also have the point, right? The point, I'm going to mark this xy here. So this is going to be 1, -0.5 to see what that would do. I think that should do it. Okay, and of course, we want to find the same thing. We want to find the coordinates. Okay, 1, -0.5. Okay, just some marking so we can see everything. This angle, what will be this? What will be this angle, right? This time I'm going to measure this angle slightly differently. I'm going to measure this angle slightly differently. We have always been measuring from counterclockwise. How about we measure this angle clockwise, right? We're going to measure this angle clockwise, right? Clockwise, there. -pi over 6, -pi over 6. For -pi over 6, right? So this angle, it's -pi over 6 because it's measured clockwise. So -pi over 6. Its reference angle is +pi over 6. With that reference angle, we can set up another triangle. So once again, this is a unilateral triangle. Then we understand that the blue is half, right? The red is √3/2. However, the blue is negative because the point is on the fourth quadrant, right? The blue is underneath the x-axis, in other words. Therefore, this point, this xy, is going to be, if I write color toned, the red number for the red horizontal, which is the x coordinate, is going to be √3/2. That's a positive. And the other one, the blue, is a -1/2. Whoops, I'm going to use the blue color. Okay, the blue color. -1/2. So once we have these two coordinates by definition, and knowing the point has the r equals to 1, and we can apply the definition. And let's see how we write it down, right? So sine of -pi over 6, we're applying definition, is the y coordinate, y over r, right? R is 1, so that's -1/2. Okay, cosine -pi over 6, okay, is equals to √3/2. √3/2. all right? It's very important that you understand how definition is used in establishing those points on the unit circle. Without that understanding, okay, it's not very useful. It's not very useful. So these three elements, angle measurement, reference angle, and definition, they all have to be seen and used in one set, all right? So that's about these cases for sine and cosine application. So let's summarize, okay, let's summarize. So we have these four cases, right? I would like you to compare this case with the other example we did in the previous video, which is they're not a special angle, right? It's a 3, 4, right? The point is 3, 4 with that example, okay? You can see the important part is use the definition properly. The important part is using definition properly. It's not about memorization. It's about how we apply these special, these special angles is to serving our understanding of the definition, okay? Summary. Okay, in this case, we have discussed the 4 cases. Okay, 4 cases, so 4 columns. Okay, so I'm going to remove those. And in these cases, we can see, right, 1, 2, 3, 4. The first case, and we use geometry. We use geometry in the rectangular system. In the rectangular system case, right? So the point is in the first quadrant, red and blue, right? I'm using red and blue. I'm going to consistently using this color coordination to make a point, okay? The red and blue. So you have the visual, we have the visual in front of us. The red and the blue, okay? In different quadrant, I also want you to compare the sign that we calculated for sine and cosine. Okay, so maybe I can make this just a little bit smaller so we'll fit on one screen. This is better. I think this is better. Okay, so these points, right? In the case of pi over 6 are reference angles. And the other angles, it could be, measured in any different ways. It just terminates in any one of these quadrants. When pi over 6 is a reference angle, okay? So summarize, when pi over 6 is a reference angle, when pi over 6 is a reference angle, right? And then we have these points, right? So let's see if we can identify this point. And this point is x comma y. In this case, when this point in the first quadrant is √3 over 2, comma 1/2, right? So that's the point, right? In the second quadrant, what's in the second quadrant? The second quadrant, the x is negative, right? In the third quadrant, and both x and y are negative. And in the fourth quadrant, negative. Sorry, the x is positive, y is negative, right? So these are the 4 cases. What if it's not a special angle pi over 6? It's the properties are going to be the same, right? So once we identify that point, right? So let's look at how we calculate all these other functions, right? Once we have identified that point, by definition, right? Look at that definition on your flashcard. Look at that definition on your flashcard. So sine of whatever angle, right, ends up on this terminal, it's going to be the y. It's going to be the y here. Okay, when it's in the first quadrant, it's going to be positive, and whatever angle it is that terminates on the second quadrant, it's going to be half, and on the third quadrant, it's going to be negative, right? The blue is negative. When it's negative, it's beneath x-axis. You can see x-axis is the sea level. Beneath it is negative, right? And for the next one, okay, and cosine, right? Cosine angle, and that's equals to what? That's equals to the red, the horizontal, right? And cosine on the second quadrant, you can see the red is negative. So cosine is negative in the second quadrant, and the cosine is negative in the third quadrant, and cosine is positive in the fourth quadrant. Continue, we can do all of these. We can do all of these angles, right? We can do all of these. Let's insert 2 more rows, maybe, and then we're gonna insert more, okay? How about tangent, right? How about tangent? Tangent of this angle is equals to what? Tangent is y over x, right? This is the y, this is x. The blue over red, right? The blue over red, y over x, which is the blue over red, right? The blue over red. And what is the blue? The blue is sine, half, and the red is √3 over 2, right? And then we simplify. We simplify. When we simplify, you can see the 2 and 2 will be reduced. And then we're going to have 1 over square root of 3. 1 over square root of 3. 1 over square root of 3, if we rationalize it, right, we multiply √3 with √3 over √3, right? Multiply by 1. Principle number 1, mathematical principle number 1 is used. So we will end up with √3 over 3. Okay, so we can find tangent this way. And tangent for this in the second quadrant, the same thing, right? So tangent in the first quadrant, in the second quadrant, it's going to be half divided by negative. So this time it's going to be negative √3 over 3. In the third quadrant, right, it's going to be negative divided by negative. That's positive principle number 6. And quadrant 4 is going to be negative over positive once again, right? And cotangent, right? Let's look at cotangent of angle that terminates in the first quadrant, right? It's going to be x over y. It's a reciprocal. So x over y. Okay, if tangent A is 1 over √3, then the reciprocal of it would just be what? Just √3, right? Because the reciprocal, they're reciprocal to each other. And so cotangent A for whatever angle that terminates here, okay, it's going to be negative √3, right? Because it's going to be x over y, okay? And for the third quadrant, right, cotangent is going to be positive again, because that's going to be negative divided by negative. And in the last quadrant is negative, right? So the one, you can see once the pair of point is found, it's pretty straightforward. Now, how about secant and cosecant? Secant, cosecant is straightforward because cosecant is the reciprocal of sine, right? It's reciprocal of sine. So cosecant of this angle is going to be the reciprocal. So it's 2, right? And the cosecant A, that's going to be it's going to be 2. And cosecant A, and this is going to be -2, and cosecant A is going to be -2. And these angles we all refer to, they're not the same, okay? They're relevant angles that terminates on the specific terminal, okay? And now for secant, okay? Secant of the angle that terminates in that first quadrant is going to be the reciprocal of it, right? You're going to take this number and put it upside down. That's going to be 2 over square root of 3. And you're going to, rationalize it, which is similar, right? So you're going to get a 2 times root 3 over 2. You may like to pause the video and do it for yourself, right? And the next one, cosine, is negative second quadrant, negative in the third quadrant. So secant A, any angle that terminates in the second or third would thus terminate on this same terminal, and that's going to be -2 times root 3 over 3. So this is going to be a negative. And the same is here, right? And the next is, the last one is a positive because secant is positive. So this, we can see in this calculation, right? In this entire calculation, once we get the points, right? Once we get the points, get the coordinates, by definition, all the functions, all the function values by their rule can be found. Okay, and we will continue to discuss the special angles. And the next time we're going to work on another special angle, which is pi over 4, just to give you a heads up, right? What is pi over 4? You can see I'm already preparing for it, right? Pi over 4 is a 45 degree. So I'll give you a heads up, okay? 45 degrees. And what is the radians of it? To convert it to radian, we take the 45 degrees and multiply pi over 180 degrees. Okay, so we will end up with pi over 4. Okay, so for pi over 4, for this angle, right, we're also going to discuss it in different quadrant, And we're going to we're working towards that, unit circle, right, with special angles, so we can use it in the future to serve our purpose. Okay, our purpose is to understand definition better. Okay, because after these discussions of the special angle, we're going to discuss other very important things that can be derived from the definition. So far, we're still applying definition. As we have emphasized at the beginning. So each one of these functions is a rule. And so in this title, I would say trig functions instead of, I should have said trig functions when inputs are special angles, right? I put sine function, and then I realized actually I have covered all trig functions. So the title should be changed, trig functions when inputs are special angles. And next time we're going to consider other special angles. It's still under the same stage, just the same stage set, okay? And you can see for all these triangles, just for all these trig functions, sorry, okay? The input are angles, okay? The input are angles and the output are ratios, okay? Different kinds of ratios, right? So for sine is this ratio, right? And for for cosine, it's a different ratio. It's x over r, but it is still a ratio. It is still a ratio, right? So we have not talked about domain and range yet. We're not talking about domain and range yet. We will. And the tangent is another ratio, right? Tangent is another ratio, but it's still a ratio, right? So this is what I wish to nail in your mind, right? When we look at the definition, right, for domain and range, domain for these trig functions, they are angles. They are angles measured from standard position. And the output, right? For each input, there's exactly one output. For that exactly one output, those outputs are ratios. Those output are ratios. And so for cotangent, same thing. For cotangent, it's the same thing. It's just a different kind of ratio, okay? So when you're working with these questions, I would like you guys to constantly reflect on the definition, on the rules, right? What kind of rule is it? What kind of rule is this function, right? So this is r over y. So I'm just going to make it a complete set, right? So you can see all of these functions, they're taking all of these 6 functions, right? Of course, we're going to have some emphasis, right? We're going to have some emphasis. And this is r over x, right? All these 6 functions, their input are angles. Angles are measured in certain way. How they are measured? They're measured from the standard position. It can be counterclockwise measurement. It can be clockwise measurement. That means it can be positive angle, negative angle. And it can be measured by degrees. It can also be measured by radians, right? So all of these are possible measurement for the angles, for the inputs, but the outputs are all ratios. Okay? Ratio that's related to the point on the terminal other than the origin. And the radius of the point of the circle where the point is on. Okay, so I hope that's a good summary for you. Okay, so this piece, what we're trying to emphasize is what a type of input we're dealing with, what type of output we're expecting. Okay, so until next time, thank you for watching.